Thank you. So this is the Cape Flats Aquifer recharge plant. It's the complex of buildings you see here. Sorry, let me just get my controls. Okay, the client was the city of Cape Town. We were the architects. The main contractor was Steph Stocks. The design of the plant was done by water and wastewater engineering, the civil design of it, and all the technicalities. We basically did the envelope designs. So we were responsible for what it looks like, but the engineers were responsible for how it works. The project brief that we got from the engineers was this Revit model that they did, where they have already designed the process plant. So it's the filtration buildings arranged according to the platforms, the gravity feed from the highest platform to the lowest platform, filtering treated effluent to a potable standard in order to recharge the aquifer to manage the levels. This project was initiated as a response to the water crisis, so that the city has a bit more control over all their various water resources and not have all their eggs in one basket. So our brief was basically to make it a world-class facility, because if it's one of the first of its kind in South Africa, and they want to take investors there to show them how progressive they are in order to raise funding, and they also wanted to use it as an educational tool, bringing schools there for visit and so on. Secondly, it's a very corrosive environment, being on the False Bay coastline with southeaster, like taking it head on. So there had to be quite a robustness in the materiality, so that the maintenance can be as low as possible. Unlike usual wastewater plants, this is not a wastewater plant, it's a water treatment plant. So the interiors of the spaces were not that aggressive as you usually get with wastewater treatment. So the steel work on the interior wasn't as much of a risk as on the exterior. So let's see, I need to get okay. So then for the part of the project brief, how does steel play a role in achieving your vision? So these long buildings are water retaining structures with filtration plants in. Each one has got a bunch of equipment in that gets operated with or moved and maintained with gantry cranes, and it's essentially open filtration tanks. So we had to achieve large stands in the buildings that's column free over the filtration areas, and together with that we needed the roof pitch to be quite shallow, and it's an asymmetrical roof construction. So we needed to do the roof construction in a way that we could achieve a very flat roof, or relatively flat roof pitch, and asymmetrical construction with a wide span, and that left us with steel as basically the only option. Because of the high winds and the corrosive environment, also we didn't want any of the overhangs or the roof eaves to be exposed, so they all sit back and are essentially what we call the clipped eave with a concrete apron, in order to be protected. There we go. Okay, then beyond aesthetics, what functional benefit will steel provide for the client's operational needs? The scheme, or the way the procurement is done in the city, it happens in two contracts. First is the civil contract, where all the civil work is built, so all the building shells essentially, and then secondly, mechanical electrical contractor gets appointed that fits all the mechanical electrical equipment in. Because it happens in two stages, we needed the roofs to be removable to install large equipment. So the roof structure was designed in bays structural bays with movement joints in between them, and with installing of the mechanical electrical equipment, they are able to remove a bay and install the equipment from the top of the crane and then close up the roof afterwards again. These colors on the right are just showing our color palette for the steel work. So we had two different color strategies. The one was a green, where the roof structure was a lighter green and the handrails a dark green, and a redder one where the roof structure was the red, light red, and the handrails a more maroon color. Okay, so just some of the overview data. Completion date was December 2024. Cost of the project more or less 341 million. So the structural, it's a structural frame roof, steel roof. The vertical load bearing members are concrete frame, and then below ground is concrete water retaining structures. And as I said, it's infrastructure, it's utility infrastructure, and it's a water treatment plant. I'm going to glance very quickly over here just to not, to be conscious of the time. So you can see the location. This area here is the False Bay Nature Reserve, with Pelican Park on the one side and almost Muizenberg on the other side. You can see the detention ponds here, and then this little grey block is where the water treatment plant sits within the Cape Flats wastewater treatment work. So it consists of the 4 linear filtration buildings that are gravity fed. Their long facades face east and west. Important aspect of the design was that we provide a pleasant environment for the operators of the plant. So that means we need to get natural lighting. But because there are water retaining structures or essentially open ponds inside the building, we needed to control the amount of natural light. So we opted for kind of treating the facade as this gilt facade, where the windows face south instead of north or east or west, and we get indirect light in from the south to still make the pleasant environment, but we can limit the algae growth due to direct sunlight. The facades of the buildings were chosen as the robust face brick and concrete to limit any maintenance and be able to withstand the corrosive environments. And ultimately, the facility is designed to really inspire to be a place that the city can be proud of, the people working there can be proud of, and that communicates that progressive stance of the city towards development, technology, and infrastructure. Quickly running through the plan. These are the linear platforms from the highest point to the lowest point. So it was important for us to place the admin building as part of the plant building, so it's not a loose little building on its own, in order to give it priority and prominence on the site. So have the necessary hierarchy of the admin building first, so that when you enter you can read immediately where to go. And then the further building downhill of that is the admin building with the media filtration at the start, then the BAC and the ozone dosing area here, then the next platform is for the transformer and acetic acid bund, and then last step is the ultraviolet filtration, and the final, the raw water pump stations. These buildings were also designed that they can be expanded later towards the backs and further to the platform that's not occupied yet, if they want to increase capacity in the future. So just a quick explanation of the facade treatment. It is, here you can see the gills that I was talking about. And at the admin area, it changes order so that it announces that this is something different with more importance, and you immediately see you have to go there. And on the side where the offices are, we actually change the orientation of the fence to face north, so we get direct sunlight into the human occupied or permanently human occupied spaces. I'll go roughly over the structural steelwork. The structural engineer it was primarily Stephen Wood. He was assisted by JG Africa, who was also they were kind of the project managers. They had the contract with the city, so they appointed all the other consultants under them. And they also assist with some of the structural design work, just in order to ensure sufficient capacity to keep up with the speed of construction on the site. Here you can see the color-coded internal steel expression of these plant rooms, where quite a bit of emphasis was placed on the color of the steel to make it something a bit more special, and then also the handrails to go with it. So steel were completed fourth month of 2024 at the cost of roughly 8.2 million and 138 tons, and that's for the structural roof frames and substructures. Then metal cladding. You can see a photograph showing all the roofs of the plant buildings. You can see the asymmetric geometry of the roofs here, and that is because of the larger span that goes over the filtration areas or ponds, and then the smaller span going over the walkway or the galleries where the operators would walk. So we kind of divided the roof into, and we introduced hipped ends, creating quite a abnormal geometry, so that we can achieve a flat roof edge with gutters right around every roof as far as possible. So cladding wise, it was about 27 tons of cladding that was done with Ultra Bond, color bonds, Ultra AZ200, color all grey, and just the clip tight 700 profile. Because of the high winds, because of the low pitch, we needed to conceal fixed profile, so that was important. Because of the high winds, it was crucial for us to make sure that it is a profile that doesn't detach in high winds. So the clip tight 700's got the reinforced bands that gives a lot more stability to the ribs where they clipped on. So it proved to be quite a good solution in order to create a sealed roof that doesn't blow off in very high winds. Cladding coverage is about 6,700 square meters. As I mentioned, structural engineers, Stephen Wood from WA Structural Design, steelwork contractor is Garth Madden from Madden Steel Projects. They also did the steel detailing, and Garth, you can chip in. You're welcome to chip in if possible. As in my mind, you were the design and supply steel contractor that the connections and all the details.
That is correct. Yes, Gustav. We were it was a design and supply project on from our side.
Yes. Ross, do you want to chat about this, or do you want me to summarize it?
I think you can summarize it. It's fine. I'll jump in if anything needs clarification.
Okay, 100%. Here you can see the cross sections of a few of the buildings. It's quite a simple structure. We've got the concrete upstand beams with apron detail. Onto that was fixed the steel rafters. Let me just quickly read through here. Yeah, okay. It was decided to use rafters to limit the structural depth so that we can achieve the low pitches with enough clearance for the gantry cranes and so forth. And the load paths are very straightforward. The loads, the steel rafters are chemically fixed to the concrete structure, and the concrete structure transfers the loads to the floor. The detailing of the rafter, all the connections were launched to compensate for the bending or the moment forces there, and it was braced by straightforward angle bracing members positioned in the plane of the roof with a few elbow elements connected to the purlins. Column fixity, steel rafters connected to the concrete columns by means of the moment resisting launched connections. Those, I think that's straightforward. Yeah, okay, that's already mentioned. So you can move on to the images, which explains it quite easily. Here you can see one of Garth's detailed drawings of the steel structure, showing the geometries at the hips and how those elements connected. The bracing, you can see over the bracing bays. You can see here it runs a movement joint, so the contractor assembled each structural bay on the ground first, the rafter plus its purlins, and then lifted it with the crane in place. And then while it was positioned in place, they fixed it chemically, just bolted it to the concrete structure. And then here you can see the concrete ring beam and columns that carries the forces down. I'm going to skip through this because Stephen, there's another structural engineer who's in the presentation. Technically, Garth, I don't know if there's any technical challenges that you want maybe just to highlight, or in terms of the installation or connection designs or anything of that.
Sorry, if you can hear me, there were no real technical challenges besides the soft ground during the erection process, made the craneage and where we set up a bit tricky. But it was nothing that we couldn't overcome. We utilized a crawler crane instead of your normal overland cranes. But other than that, nothing technically difficult about the assembly and installation of the structure.
Yeah, you can see these are the members that was pre-manufactured at Madden Steel, delivered to site, back out here, and then assembled on the ground. And here's the crawler crane that's busy working there. And here you can see a structural bay that was pre-assembled and then lifted in place and fixed with these launched connections and base plates to the concrete structure. Here's another image of the roof erection and cladding, where the steel is nice still exposed. You can see the green here where the structure is still exposed, and the red. Now that works together. There's some images of the interiors of the final spaces. Showing the effect that the colors has on the quality of the spaces. So this is the machine room at the BAC, and this is the media filtration area. Okay, so metal cladding or roofing then. So cladding manufacturer, BlueScope Steel, South African, Indian Ocean Islands. Role form or profiler was Global Roofing Solutions. They're also the supplier. The cladding contractor was Chartwell, and then the paintwork contractor, MRH Blasting and Coatings. This is just basically an overview of the profile we chose that I already explained, which was the clip tight 700 and obviously AZ200 coating thickness because of the proximity to the ocean. It offers exceptional long-term durability, corrosion resistance, reduced maintenance, recyclability, and
good stuff.
Lifecycle environmental impact. Yes, Sean.
Sorry, if you want, I can drive this.
Yeah, sure.
Makes it easier for you. Okay, so yes. As you can remember, initially we were invited by yourself and the team at Stef Stocks to discuss our most suitable or recommendation for the build, considering yes. Obviously the plant, the internal atmosphere and environment, and then as well as where it's situated. So all of the cladding parties came together, and just based on the long-term performance and the data that we've got with regards to colorbond steel in the coastal environments and highly corrosive areas, we then suggested or specified that colorbond steel AZ200 or Colorbond Ultra be used for this. And then GRS came and they suggested using clip tight for the wind stability or resistance to blowing off of the sheets. And I think the main reason there is, as you said in the first couple of slides, the requirement from the City of Cape Town was to obviously showcase this unique one-of-a-kind build, but also for sustainability and future investment into infrastructure projects. They needed something that can last in that environment and be fit for purpose, meeting all the environmental and sustainability routes, but also stay there for a very long time. And I think that was the important reason why this specification was then drawn up for the cladding to last as long as possible. That's fine.
Thanks, John.
Thank you.
Yeah, you can see a drone shot of the roofs of the buildings. Just a few side images of the installed cladding, the movement joint details over the movement joints. Another drone image of the building cladding, the cladding being done here. At this stage, the external work still needed to be done. Okay, then going to fabrication. I'm gonna skip that last one. I'll go back up. There we go. Just quickly going over this again. At Manual Steel, they pre-manufactured and pre-welded everything in the workshop. Obviously, based on what sizes could be transported to site, and then assembled it on site, installed it there. So the city was very specific on the quality control. So the welding was inspected on site. It was inspected in the workshop and again on site. That goes for the coatings as well. So there was a quality control check at Madden Steel by the city themselves or some of the resident engineers of the weldings, and then again when it was on site, especially for the paintwork. And then sometimes if something had to be fixed or redone, they had to take it back to the workshop to work on it in a controlled environment. So no steel fabrication or manufacturing work was done on site. Everything was done at Madden Steel's that was off-site. This is not really fabrication images, this is just construction images. Okay, erection or construction installation. Got 3 minutes left. Erection challenges was as Gus mentioned, the space constraints and the sandy conditions on the site. It made it very difficult. It was also that was kind of the main challenge. But it's obviously not a unresolvable challenge, so they just demarcated various areas to not interfere with different trades. And then, yeah, I think these things we've already addressed. Challenges and solutions. In general, just to kind of end off the most significant challenges was the severe environmental challenges or the severity of the environment and making sure everything is protected against the environment. And then also to prevent to create a human space, but also enabling the process to work optimally without too much direct light and algae growth. So quite a straightforward challenge. The innovative solutions were the facade strategy that I already explained, and material contrast and durability. So the materials that were chosen for the various components of the building envelope, which are obviously in the wall and the roof. This is just then some more images of the final building products. And then the benefits of steel in the application was primarily to lean on the high strength to weight ratio by spanning large volumes with relatively little material. As you can see in this image here, the larger span over the filtration areas and then the smaller span over the galleries. Then obviously being able to absolutely enclose and waterproof the roof surface and not and have a fairly maintenance-free and non-leaking roof as far as possible compared to other options. Okay, and then also to give us the flexibility of assembling them on site and putting them in place with a crane that enabled the roof to go up very quickly, and they can finish the interiors of the spaces. So it assisted greatly with the contractors programming so that they could move faster and not having to wait for props or curing of slabs and props and so on. So the envelope could be closed very quick, and then in the next phase of the M&E contract open up again for installation of some of the equipment. The finishing specification, it was galvanized and pre-painted all in the controlled environment of the workshop with a very high specification of paint requirements, but it's also a standard requirement for the city of Cape Town's structural steel finishing in these environments. And that is in order to reduce the frequency of the maintenance cycles, prevent degradation from asphalt spray, and guarantees long-term structural integrity. Then, Johan, we already mentioned the advantages of the color bond and using that. Another great advantage of the system we have here is that you can see the XPS insulation that's over purlin, which is 80mm thick insulation. So this composition allowed us a significant thickness of installation. So we can drastically improve the internal living conditions for the operators, and also in that way passively ensure the climate control of the building and not having to rely on air-conditioned spaces. Okay, this is just a table from Colorbond with all the product data and attributes. And here we're listing under the quality assurance the inspections that was done in the steel fabricators workshop by the city, as well as all coating thicknesses measured in the workshop and again on site, as well as visual inspections of any damage to the coatings on site. And the paint specification was the duplex system after galvanizing. That's basically a two-part epoxy primer with thicknesses, as mentioned here in microns. Okay. Weasel, are we looking for time? Do we need to wrap it up?
Yes, please.
Okay. I think I'm going to skip through that slide, then it's very straightforward. I think just maybe you can see the project team, everybody involved, and I think what we're most proud of is that the outcome of the building is really something exceptional that achieved the client's requirements of being a showcase building for international standards for especially city utilities, and showing in that way that the city is really investing in all regards, as well as prioritizing excellence and a really progressive stance towards development and advancements in all areas, not only the nice things that people see every day, but also on the wastewater plant sites. Thank you very much.